Okay, 2019 question number 1. Part A. How many fish enter the lake over the 5-hour period from midnight, and they're kind enough to say what time midnight is, to 5 a.m., also telling you what time that is. But do read all the words. Nearest whole number. So you are needing to write the integral on your answer, 0 to 5. You can write the function here in the name of it instead of writing the expression. Writing the expression is a bad idea. You can write something wrong and then you're incorrect. Plug these two functions in your calculator and double check that you've put them in correctly. And remind yourself who's the y1 and who's the y2. So I'm going to put y1 and y2 to remind myself. Now, to solve this integral, you guys know how to do that. I'm going to do that in the Desmos version. So in Desmos, I can integrate if I go to miscellaneous, and then I say 0, 5, and I'm integrating my f of x function, dx, gives me the number 153.457. We are to round to the nearest whole number. 153 is then the number that we have to write. And you get 1 point for writing the integral, 1 point for writing the answer. If you don't have the integral, you might not get the answer point for that. So very important, you always have to write your definite integrals that you're using. B, what is the average number of fish that leave the lake over the 5-hour period? So with leaving the lake, I am integrating the leave function. But it wants the average number of fish that leave. Now, let's hold on a second and look at this phrase very carefully. They want the average of the number that leave. This is the rate at which fish, the rate at which, I'm trying to speak, the rate at which fish leave the lake. This is not the number of fish that leave the lake. This wants the average number of fish that leave the lake. So I can find, what am I doing? Hold on. Or am I overthinking it? I'm overthinking it, aren't I? I am. So I'm just finding the average value. So I use the average value formula of the integral, and I'm just going to throw that in there. Come on, Desmos. So I'm going to save my time and just go 1/5, and then I'm going to change this to my other function, and 6.059 would be the average value, and that would be the correct answer. Okay, so you just write that number down, and then you move on to part C, which is what people were wanting to see. Yeah, okay. C, at what time between 0 and 8 is the greatest number of fish in the lake, and we need to justify our answer. So we want to look at what is the total number of fish in the lake. The total number of fish in the lake is the integral of these two. Oh, we've got 10 minutes left. Darn it. Wanted to get more done. Okay. The total number of fish is rate at which they enter minus rate at which they leave. But I need to integrate that to get the actual number of fish who leave. Now, if I want to find the greatest value, I need to look at the derivative. I need to look at what makes the rate of change equal to 0. The rate of change is the enter minus the leave. So I need to find out when is this equal to 0. With your calculator, you want to make a third function where you are subtracting these two. I'm going to get rid of this, and I'm going to write f of x minus g of x. Yeah, it's a graphing calculator problem. I'm going to deselect these two, and then I want to remember that it gave me an interval. It gave me an interval from 0 to 8. So going back to my calculator, between 0 and 8, I have one solution, 6.204 is the time. So it asks, what is the time that it is greatest? But I've got to justify that time. And you have to do an absolute justification, not a relative justification. Because there is only one critical number, and that critical number is where you optimize. You are allowed to do the following. The interval is 0 to 8. You are allowed to say that the function e minus L is either positive or negative over the interval from 0 to 6.204. I'm going to look at my graph. E minus L is positive because I'm up here above the x-axis. So greater than 0. E minus L is less, is less than 0 over the interval from 6.204 to 8. That justifies that the absolute maximum occurs at t equals 6.204. But if you just say that E minus L changes from positive to negative at that number, you will not get the justification credit. And finally, D is the rate of change in the number of fish in the lake increasing or decreasing at a particular time. So, rate of change in the number of fish is E of t minus L of t. And we want to know if that is increasing or decreasing at t equals 5. Since you have a calculator, you just need to know, is the derivative of this function positive or negative? So if you go back to your graphing calculator and you look at that subtraction, and you look at t equals 5, can you see at t equals 5 it is decreasing? That this graph is heading down. From left to right, it is heading down. So f minus g is decreasing, but you have to explain how you know. It is decreasing because, and you have to explain in derivatives. You can't say, you don't want to say because this graph is heading down. You need to say because the derivative of E minus L is less than 0 at t equals 5. You have to express that that is why. Now, I see on the answer key that it gives the actual derivative number. But the explanation of saying that that rate of change is negative is what they need. Yeah. Yes. In fact, that's the way they wrote it in their answer sheet. Yeah. Mm-hmm. Yeah. Any way that you express, because there are so many ways of expressing derivative, just make sure that you're expressing derivative of that. And so you can, come on, you can write E prime minus L prime is less than 0. Okay, that is the end of this problem.